Hi everyone, and welcome to another episode of our podcast. Today we have Karim Rabie. Karim is an old friend of mine and a colleague. We worked a lot before, many years. Karim is a ICT consultant with 15 years of experience. He's currently holding the position of ICT Chief Architect at NEC, and previously he worked as a technical consultant at Netcrackers, Tech Mahindra, STC, Nokia. Karim is a well-known in SDN and NFV industry. He actually participated in the ETSI NFV architecture along with other standard bodies like Open NFV, ITU, and so on. So we are happy to have you, Karim, with us today, and thank you to allocate the time to share with us your experience in 5G.
Thank you, Radwan. It's my pleasure to be here. It's a very interesting topic for today, the 5G, and I'm really excited to start.
Exactly, yeah. Karim, for sure, we worked before in maybe France Telecom, and I'm a guy which you can say it's like more into IP domain. I worked a lot with service provider in MPLS and internet service provider and so on. So usually for me, and I believe for a lot of the audience, 5G is not our core business or core competence. 5G is something like one of the services which uses the networks and the service providers. So I believe it would be great if we start telling us a bit of history of 5G timeline, and then we can discuss what are the drivers and why people start thinking about 5G and upgrading from the existing 4G.
Yeah, exactly. Yeah. Actually, I share the same feeling because I started having a background on IP and transport and MPLS, and then I moved to the mobile broadband. So I used to have the same feelings. So for the 5G technology, it's very I'd say important to understand the term G, which is the generation. So that's how normally we I would say categorize the stages or the life cycle of the wireless technology. We do that based on generations. So actually we have 1G, 2G, 3G, 4G, and now we are exploring the 5G. So just a quick historical background. The 1G was actually the old technology delivering voice service using analog technology. That was like in the late 70s with the first commercial deployment in NTT Docomo in Japan. And then this thing started to evolve, and we introduced delivering the same service like voice, adding SMS and some other services, non-data services through digital communication, and that was a 2G. I'm sure you remember the term GSM, the global system for mobile communication, and that was somehow in the early 90s, having the first commercial deployment in 1991. And then things started to evolve, introducing what was known as GPRS. By that time, it was called 2.5G, and then the Edge 2.75G.
Exactly.
Yeah, I'm sure every one of us must have seen the term or the letter E on his mobile when he's covered by 2G. And that's for sure the worst data experience that anyone can have.
But exactly. And when you see this E or Edge, you feel really bad. But oh my God.
Yes. But actually, but by 1998, that was the most innovative thing in data, reaching a throughput of 384 kilobit per second. So that was the evolution in the data technology using the 2G in 1998. And then in 1999, or what we call release 99, the 3G was introduced, the UMTS. And by the standardization and the innovation technology, we could reach almost 2 megabit per second in uplink and downlink. So in every time we go from a G to a G, like from 2G to 3G, there is commonly a shift in the architecture of the core and the radio. So starting from 3G, you start to hear some terms like GGS and SGS, and those nodes that actually are delivering mobile broadband services in the 3G.
So starting from release 99 and actually till release 8, which is the LTE, we had several releases like release 4, release 5, and release 6, and release 7. Release 4 introduced the concept of all IP network. So starting from R4, we had some, I would say, framework for all IP core mobile core network. In release 5, it's very well known of introducing the IMS, and in release 6, it uh, it had some radio features in bringing the HSUPA, the high-speed uplink packet access, and we could give like a boost for the megabit for the throughput on the uplink. In the R7, it's a very well known of introducing the direct tunnel feature, where to the first time you could bypass the SGSN and go directly from the RNC from 3G to GGSN. And the evolution continued till we reach the R8. So the R8 is a very important release where the 4G or the LTE was introduced, bringing a new core architecture, bringing new core nodes like the MME, the S gateway, and P gateway, and introducing the new E node B, combining the functionality of node B and RNC. And that was the, I would say, the kickoff of the 4G R8 to the first commercial deployment in Finland in 2009. What was significant in release 8 was the direction of not having a circuit switched domain, in the sense that EPC or Evolved Packet Core would serve both voice services and data services. So by that time, the concept of voice over LTE VoLTE was introduced, and we started to have like a one unified core delivering data and voice services. We for sure there was some framework for interworking with circuit switched components like MSC and media gateways in case of something called CS fallback. But since that time, the evolution continued on, evolving and enhancing the mobile core, focusing on the mobile data services. Aligned to the name long-term evolution, the evolution didn't stop, and releases like R9, R10, R11, R12, R13, and R14 were introduced from I think the duration from 2009 till 2017. From core perspective, R13 and R14 provided the framework for dedicated core, which was I would say the initial stage for network slicing. R13 is a very well-known release of IoT and M2M. So there are a lot of specifications related to M2M and IoT in R13. Similarly, R10 also was known of the LTE Advance, which is somehow thought to be the standard 4G deployment, fulfilling the 4G throughput figures. And following I would say the timeline on 2015, that was one of the main initial milestones of the 5G by the ITU publishing the IMT 2020, the International Mobile Telecommunications 2020, which actually listed the 5G requirements with some expectations to complete the standardization by 2020. So when you see this ultra latency requirement, user throughput requirements, and the mobility, all these were grouped in the IMT 2020. So the document was published on 2015, and that was I personally I think that's one of the initial motivations, or I would say the kickoff for the 5G. So 3GPP has completed doing the standardization of 5G, the same work it was doing for 3G and 4G. And release 15, 3GPP release 15 handled what they called the phase one of 5G standardization, and the standardization were released in, I would say, were frozen in March 2019. So the specs were there in March 2019. And the phase two of 5G started with release 16. And by the way, release 16 is expected to be frozen and to be published this month in March 2020. So that's actually the timeline from the 1G to 5G. Currently, we started to see the announcements from the operators doing either deployments of the 5G NSA, and we will talk about that, or some POCs about 5G SA, and actually some of them are starting the live deployments of the standalone deployment of the 5G. So that's the story, I would say, for the mobile broadband from the 1979 till 2020 till this year.
Great. Yeah. Thank you for this trip in history journey in the past 50 years quickly in 5 minutes. Two things, Karim. I noticed that when you describe these different generations, it's mainly about the data. And we know for mobile, maybe 1G, 2G, 3G data was not the main uh, services for G. It was the mobile. Is there also enhancement in the mobile calls itself, quality and so on, or
Yeah.
this mainly for the data and bandwidth and so on?
Yeah, it's a very good question. Yeah, so in the 2G era and the 3G, there was some sort of dedicated core, and providing services for voice, and that's completely isolated from the core delivering the data services. But starting from 4G, we start to have technologies like voice over LTE, which actually realize the voice services across or via the data core. So in the 4G, the 4G core, one of the most unique things about the 4G core and basically the 5G core, that there is no actually what we call circuit switching core. There is no core dedicated for voice. It's one unified core delivering both data and it's one unified. Yeah, there was some sort of okay. So I'll just repeat that. So starting from 4G and 5G core, it is one unified core delivering both voice and data services. So it's all fulfilled through one core. It's unlike the 3G and 2G days where you have a dedicated core for voice services.
Yeah, thank you for that. That's great. So if we start discussing the drivers, is it really, from my maybe reading and interaction with 5G, a lot of people mentioning that sometimes, in many cases, one of the main drivers that you have a big event happening, like as example, a World Cup or Olympics, as example, people were actually trying to introduce 5G before Tokyo Olympics this year, and also considering the World Cup in 2022. So this some of the drivers to start thinking about giving the user better experience, giving him similar experience in his phone, like he's working in his mobile broadband at home. What else? What other drivers drive these technologies and this enhancement, which is happening? It was happening maybe every 10 years, and now people start seeing this new generation maybe in this time. Maybe people start talking about 6G now already.
Yeah. I do agree that there are certain drivers, and unfortunately, they are very different from the driver that took us from 3G to 4G, and these I would say previous generations. The main difference that now the operators are looking for new streams of revenue. Okay, because the old stream of revenue, which is actually the data pipe, giving pipeline for users to just to consume data, and not to provide any services, just to be I would say the pipe or the transport for any overlay service. This is not, I mean, I would say this is not the right choice for 5G. The 5G actually is what I call is a very service oriented or business service oriented technology. So the standards are there to fulfill use cases, to fulfill services, to bring monetization framework to operators. So if you ask me about the drivers, and actually there were many surveys done surveying operators back in 2014, 2015, the main drivers was actually fulfilling new set of use cases of services, maybe related to IoT, to smart cities, to what we say mission critical services, to new applications like
augmented reality, virtual
like AR and VR, and actually not just fulfilling that from technology, not just realizing that from technology perspective, but also from monetization perspective. They want, okay, we want to fulfill a technology, and then we want to get money, get revenue out of it. So these are the real drivers of 5G, to enable new services, to engage new, I would say, markets, new verticals, to engage directly with the enterprises, not only just offering a pipeline or a pipe for users to consume data, and that's it. So I believe that's the main difference.
Exactly, yeah. And this is actually raised a question to myself, and actually I was reading a couple of articles that maybe, let's say, for a big operator in US or this huge geographical countries, for an operator to invest maybe billions of dollars to actually establish this 5G in radio, which actually really expensive, and also in the core, what would be the return on investment? This operator will spend billions of dollars, and now most of, if we say the mobile users, they pay fixed rate, and they have unlimited calls and unlimited data. So how to add this extra service, and will the end user using his mobile will agree to pay extra money because it's 5G? Maybe he would say, no, I'm happy with the 4G. Why should I pay more?
Yes, exactly. I mean, if you are a user and you are seeing like 4G written on your top of your mobile, then you are covered by 4G, and you are you are consuming data, and then suddenly it became 5G, and you still consume data. So what is the difference? You're not paying anything. There are there are previous services, for example, something like VoLTE, voice over LTE. Do you care really if you are being served, your voice call being served by LTE or by 3G, by 2G, as long as the call is successful and voice is clear? That's it.
Yeah,
you still really care. Exactly. So now before investment in such huge new radio, before investment in going to edge and deploy edge pops, you first of all the operator must define the services, must see it from business perspective. What are the services that I'm going to deploy, and what is the ROI, as you said? If you don't do that, then for sure it's the business case will not fly.
Yeah. So as you mentioned, maybe they need to start, and I believe they already did, looking for new markets. So maybe, as you said, IoT. So to cover all this, maybe, but we're expecting billions of sensors connected and transmitting data. Maybe factories, which also will start using a lot of sensors and so on. So I believe in the next slide we can also cover some of these.
Sure. Sure.
Thank you, Karim. Another question, and also it's related to this. When you mentioned the standard bodies defining 5G, we're all aware of 3GPP. So is there any other body? Is ITU having any impact on that? Are they defining the requirement in 3GPP, defining the architecture this requirement, or who else is really influencing the 5G standard?
So I bet that whoever following the 5G technology will be, I would say, will observe the number of entities that actually doing some contributions in the 5G, and this may do or may make some confusion, for the technology. But in general, the 3GPP has been always the main home of standardization for the mobile wireless technology. So starting from 2G. So 3GPP actually was established in 1998 for the sake of doing the 3G standardization, and that's why it was called third generation. And then it completed their work doing the standardization for 4G and 5G. But there are other entities surrounding the 3GPP in a way or another. For example, the 3GPP has some what we call organization partners. So these organization partners actually they have some sort of liaisons going and between these entities and the 3GPP. Let's say, for example, ITSI, European Telecommunication Standardization Institute. So it is an organization partner for 3GPP. So there are a lot of mutual cooperation between them. And also there are some other partners called market representation partners. Those partners actually are responsible to give the market feel and the insights to 3GPP, and somehow influence the direction of 3GPP. And these partners are, I can give you some examples. I'm sure you've heard about GSMA, NGMN. So all these are like example of the market representation partners of 3GPP. For ITU, ITU actually it is a UN specialized agency for information and communication technology. And it was, like established in 1880 something. So it's a very old enterprise. It is responsible of allocating the global spectrum for countries. So somehow ITU is providing requirements to 3GPP and other standardization bodies. I give you one clear example. The latency requirement, the throughput requirements, the density requirements, the mobility requirements for 5G, for 4G are all coming from ITU. So when you hear the term ultra latency 1 millisecond, and it was in 4G 10 milliseconds, these are all requirements placed by ITU. So ITU, they put the requirements, they give them guidance for 3GPP and other standardization bodies, and standardization bodies, they try with what they call by stage 1, stage 2, stage 3 standardization to fulfill these requirements. And this is the case in the 5G as well.
Great explanation. Thank you, Karim, for that. I believe everybody will now have better understanding of 5G. So if we start getting more deep dive into the technicality, I don't want to repeat and explain again each building blocks of 5G, but if you can just explain to us the main differences between 5G and 4G. We know that 4G we have in the radio A node B mainly, and then we have what we call it APC or enhanced packet core, and all this component as a mobile core, which, as you mentioned, is almost 100% IP now. So what are the differences between 5G proposed standard and deployment currently in the field and 4G?
Okay, the most significant, I would say, difference, and that was some sort of like starting a new era in the telecommunications. It was the service-based architecture. So we have been almost used in 4G and 3G to have some sort of reference architecture. So we know that the network consists of different network functions. Each network function is integrated to another network function with a very standard interface, which has very well defined procedures, and the 3GPP standardize all this framework into bits and bytes. But
exactly, I still remember the GI, GX, and all this.
Exactly.
Exactly. Take care of the network, yeah.
Yeah, but the new thing that now all these control nodes in the 5G are somehow integrated and interconnected through message bus. So they are all the interfaces now, or the control interfaces became, I would say the majority of the control interfaces became API based. So they are all API based, REST APIs based on JSON. So each network function expose services, each network function consume services. So it's very, what they call it, I would say, service-based architecture is not just a reference architecture. So now it's time, to have innovative use cases, because it's now any node can communicate to any node, consuming whatever service exposed by the other node. So this somehow facilitated, I would say, fulfilling new services like network slicing, dynamic network slicing, also
programmability as example.
Exactly.
More like a programming now. Yeah.
Think of leasing a network slice to an enterprise and give them the right APIs for them to govern and manage their slice. This was not the case in the 4G. This is not even, I would say, in the scope of 4G or 3G. No one thought about it, actually. I remember 3 years back, I did an assessment for most of the 4G vendors. And under the topic innovation and openness, I asked all of them, does your network function expose APIs, any kind of APIs? So the majority said no. And the only few of them exposed some internal custom APIs for their EMS, for example, to manage the node. So this idea was not there at all. And with the 5G, this is really a big difference. The other thing in the 5G that the CUPS, the control and user plane separation, became a part of the architecture. It was a feature introduced in release 14, which is a pre-5G release. So it's part of 4G, I would say, technology. But there was no real adoption in the market. But in 5G, there is a clear control plane and user plane separation. So now you can have, for example, the control plane somehow residing in the regional sites and the core sites, and you have the user plane, which is the user plane function, UPF, for example, collocated or with an edge DC or something like that. So these are the main differentiators between the 5G and the 4G.
Yeah, thank you. That's great. And regarding the cups, Karim, just to make sure everybody is on the same understanding. For us, when we talk about 4G, we know that you have mobile core, which is controlling your edge, controlling your RAN and the user traffic coming from the RAN. You have to hit the core and then decide what shall we do with this. When you're talking about cups, does this mean that we have like maybe distributed control, that some of the control functionality will be closer to the end user, or what?
Okay, so the cups from the standardization perspective from 3GPP, okay, and it's all related, to the core as a core technology. So it gives you the flexibility to decouple, I would say, the control plane from user plane. It gives you the flexibility to have multiple user plane ends for one control plane. So, but the deployment option, where to put the controller, where to put the user plane, is a very operator specific. So it's based on the use case, on the service. What I see now, that the direction is to keep the control plane in the core sites, because this is where it was always placed, and start to distribute the user plane. For example, if you want to have a use case where you need a local breakout at the edge, you don't need the traffic to traverse your whatever OLT or whatever aggregation and whatever core, and you need that just to stay on the edge. So you put the user plane, the UPF of the 5G, and you put whatever service you want to put, like content optimization or whatever, and then you do a local breakout from the edge. So again, the placement for control plane and user plane, it's a very operator specific according to the use case.
Yeah, that's good. And also, I believe the new trend and the network, I believe they are somehow related, because actually they are happening in almost the same decade. So this also remind me of, we discussed about now all the component support REST API, which is more like also programmability. Everybody now is pushing the network also to support REST API, and treating the network, which was always like a black box, treated like an application which can be steered from the end user, and you can actually, as an application, you can choose how you want to steer your traffic into the network in a specific path with a specific requirement. This will lead us to segment routing. Maybe we can discuss it. We'll discuss it in next few minutes. And also, cups, it's also, I think it's somehow related, shall we say, it's also related to SDN, the concept of also separation of control plane and data plane in the network, and having controller and
So it's a very similar, but it's a very also important to understand that the term cups exist in different domains and in different technologies. So in each domain, it has a specific definition. So there's cups, as you said, for sure, in the SDN. And I give you also one good point. At the beginning of the cups in the mobile broadband or in the core technology, starting on maybe in 2014, there was some sort of custom vendor implementation of cups, splitting the user plane and control plane of network function in the mobile broadband using some sort of SDN interfaces, something like OpenFlow, something like that. That was their understanding to the cups, and it seemed logic by that time, because it is very similar to SDN. And then 3GPP standardized a protocol that actually I would say enabled the control plane to manage the user plane functions with a new protocol by 3GPP. So it's not following now the SDN protocols, but as a concept, it is there. And as a concept, it exists in multiple domains. It exists in SDN, and I know it exists also in the radio. It exists in the core. It exists everywhere. But when you talk to someone from mobile broadband background, when you talk about the cups, then he is referring to the split in the architecture of the 4G. You know the 4G, it has this S gateway and a P gateway, right?
Yeah, exactly. Yeah.
So with the cups, we started to have S gateway C and P gateway C and something called TDFC, and then we have S gateway U and P gateway U and TDFU. In reality, the adoption was very weak, and it was justified because most of the vendors and most of the operators were waiting for the 5G. They said, okay, let's not invest in the caps in the 4G because it is there in the 5G by the architecture itself.
Yeah, that's great. This will lead us, Karim, to give us more insight about, maybe not in detail, but just the main building blocks of 5G and what are the common blocks to 4G, which maybe the operator can keep for a while, and which are the components which completely new in the 5G.
Okay, it's a little bit tricky question because if you see it from a standards perspective, then the 5G is a whole complete suite of components or network that is completely different from the 4G. So, for example, if you're having a greenfield 5G, then you're going to bring the new radio, the NG Node B or 5G Node B. That's another Node B, not even the 4G one. You will start to have components such as the AMF, which is Access and Mobility Management Function, and Access Mobility Management Function. Even from the name, it looks like the MME in the 4G, the one interfacing the radio. Okay, but the question is, and this question is addressed to the vendors: can you upgrade your MME to AMF? Can your node host the two functionalities? This is a question to the vendors, and the answer, the majority, is no. It's a new node. Some of them having a combined node in future, but the majority is no. Again, UPF, user plane function, it looks like the P gateway in the 4G. So can we collocate them in one node? So this question also is addressed to the vendors. So the main core nodes in the 5G, just because I said that implicitly, we have the AMF, Access and Mobility Management Function, and we have the SMF, Session Management Function, and we have the UPF, User Plane Function, and it looks like somehow maps to the MME, S gateway, and P gateway. And in the radio, we used to have the E node B in the 4G, and we have the NG node B or the 5G node B in the 5G. The control blocks, the one that we had in the 4G, like PCRF, OCS, HSS, EIR, and these kind of things are still there, but with new terms, with new capabilities being able to integrate through APIs. So we have the PCF, which is Policy Control Function, similar to PCRF. So again, the question for the vendor who owns the PCRF: can your PCRF act as a PCF? Can it understand the APIs for 5G? If yes, then they will be collocated in one box. If not, then there will be two different boxes or different functional blocks. And we have the UDM, Unified Data Function, and we have the Authentication Server Function, AUSF, and these are the functions that were there in the HSS. And so this is some sort of mapping to 4G, but we have new functional blocks that were not there before in the 4G. Something like the NSSF, Network Slice Selection Function. It's a very, very smart functional block that help you to, I would say, dynamically select and provision the right slice for the right customer. Okay, and we have the Network Exposure Function, and we have the Network NRF, the Network Function Repository Function. These are like some sort of the exposure function is, for example, if you have some sort of network with some complexity, so you need some sort of API level to expose the capability of this network. So the NEF, the network exposure function, is doing that. The NRF is some sort of repository to the 5G components. It looks like people who was working with OpenStack. For example, it looks like the Keystone component, the one that you have to communicate first to get the token and get the endpoints of the project or the component that you need to contact. So you see, it's a complete shift, and a new way of thinking of designing the new blocks. Currently, I'm sure we will talk about the deployment modes, but
Exactly, I was going to.
yeah. So currently, we are in the. I would say not currently. I would say 1 year back we started the non-standalone deployments, and in the non-standalone deployment, the NSA deployments, you keep your 4G core, but you do some sort of enhancements on this 4G core to be able to integrate.
Exactly.
Yeah. So I'm sure you talk about that.
Yeah, thank you for that, Karim. But just to also one question, because the name network, the word network, mean also different things for different people. Especially, we have some audience mainly from transport and also some audience from network, because one of the main, new differentiating about 5G is there are things that they can provide different requirement and different solutions to different users. As we mentioned, we can have massive IoT with the requirement. We can have ultra reliable, low latency communication, URLLC, and in addition to the enhanced mobile broadband. So when you're talking about network slicing, do you mean that slicing the RAN network, the radio itself, to give different performance to each one of them, or you can extend this slicing to the transport network itself?
Okay, this is a very good question. So there are two main points. First of all, the standard structure of a slice actually is implied that it consists of 3 slice subnets or 3 subslices in 3 domains. These domains are actually the RAN, the transport, and the core. Okay.
Sure.
So transport is there, part of the whole slice, and owns a subnet of this slice. So there is a subnet of the slice running on the transport. It's a little bit vague for people working on the mobile broadband, because 3GPP does not do the standardization of transport. Okay. So this part, and I'm sure you're very familiar with that it comes mainly from IETF, for example, not from 3GPP. So
Sure.
So from requirements perspective, the slice, an end-to-end slice consists of these 3 slices. How to fulfill the slice portion in each domain, this is still a question. Why a question? Because in some domains it's somehow mature. For example, in the core, it is very clearly defined in CPC, and the operators are starting to do POCs, and so on and so forth. And in the radio, it is there, but I would say from my readings and from the vendor readiness and from operators roadmap, it is still a little bit not defined how you do the splicing in the radio, because in the radio there are not too much component there. You have only like the DU and the CU, centralized unit, and the CU can have multiple CU user planes. So maybe multiple CU user plane can reside in multiple network slices. It's not clear yet how we'll do that. And in the transport, from a mobile perspective, it's not clear how slice would be mapped to transport. Will it be, for example, a dedicated LSP in the MPLS network that is going to be I don't know, dynamically changed according to some conditions related to slice, some SLAs, for example? So let me ask you this question, Ashley. How do you see a slice in a transport domain?
Sure. Yeah. As you mentioned, Karim, you can make it, like even in network, when you go to segmentation, you can do it very simple. You can start from everything is virtual or logical, or you can go to the highest level of segmentation that you have physical separation. So in the old days, as example, and when it comes to security, and when we used to build maybe transport network, in some situation, you would build a network maybe for IP and another network for some secure traffic, maybe for building management control and so on. Currently, we can deliver this simply by maybe that's why that operator can decide how advanced in technologies they are. For example, if they are still using some what now we call it a bit legacy technologies, it can be just a VRF, and this VRF, it can give it a different quality of service, which based on the vendor and based on the software and feature, maybe you cannot actually give differentiation if it's just just a VRF, which is virtual routing and forwarding. But now in the industry, people talking about one old idea which is becoming back to life again. Remember the old days, the ISIS, and also for something called multi-topology routing. So if you have maybe a network, you can start building like different topologies. So you can say router 1, 2, 3, 4, 5 will be in topology 1, router 7, 8, 9 will be topology 2, and router 10, 11 will be in topology 3. And even this network is physically connected. You will have 3 different routing, and each one of these slices will serve specific requirements. So maybe the first slice will be for IoT, which require less bandwidth and dense devices, while and so on. This is coming into segment routing, which some ideas like flex algo. I believe I can discuss it in another session, but hopefully this answers your question.
Because the network slice by nature it is dynamic, it is on demand. So we need to abstract all this complexity by SDN, by transport domain orchestration, by something that enable us to do such thing. Just turn it on, turn it off, change the path.
Yeah. So just to summarize again, so you can segment or do network slicing differently, starting from, even people can say different VLANs, maybe different MPLS, different VRF. You can give it even more enhancement, like create different traffic engineering and give each traffic engineering tunnel the specific requirement from bandwidth, from delay, and so on. Or if you are actually riding the wave of the cutting edge and having something like segment routing, you can even start actually almost physically or segmented your network with this, what we call it, flex algo, or creating like instance of your network. Each instance support, maybe one of them will be more concerned about the delay, another slice for bandwidth, and a third slice maybe for routing metric, and so on. So this is what I can see, how we can how operator now adapting segmentation based on their current network and what are the devices, the IP devices support and software features.
Well, this like an evidence that whoever wants to actually to realize an end-to-end dynamic slicing, dynamic 5G slicing, 5G dynamic slicing, this is like it's not like a department work or a teamwork. It's somehow an exercise that needs to be done by the full, I would say, teams and departments in the ISP. So it's starting from the RAN and the transport and in the orchestration.
And as we mentioned, maybe it's a good point to conclude this first part of our session. We talked about the main building blocks and how it's different and how it's correlate with 5G. But just if you give us quickly an overview, we hear a lot about Open RAN and vRAN, and also how orchestration and SDN, maybe cloud, can help and integrate with 5G.
Okay, so Open RAN is Open RAN is a very trending, I would say, direction in the community. There are multiple initiatives in the community. I can name the TIP, Telco Infra Project, and the ORAN Alliance. So the terms, we have been hearing the term vRAN and Cloud RAN for a while, for the last maybe I'd say 3 years. So if you talk about the vRAN and CRAN, and you may get some vendor specific definitions. Okay, so basically the vRAN from vendor side is just the capability, to split the radio stack keeping the RRH, which is the radio part still in the BTS, and getting the logic, I would say, or the BBH, the one that do all the magic, like RRC and the other RLC and this radio layers, higher layers, that having this part virtualized, maybe keeping this part centralized to manage multiple RRH. So whenever a vendor succeed to do this split and virtualize this high-level splitted part, which is the BBH, on some sort of virtualized platform, they call it vRAN and CRAN. But in reality, there is no so much innovation in that, I would say, because it's a very coupled solution. So it's still the BBH or the virtualized BBH belongs to the same vendor. It is most probably virtualized on his own virtualization software, his own distro, and it comes with his own hardware. So there is no real, I would say, innovation or any kind of disrupting technology here. So what O-RAN?
Not yet.
Yeah,
so
but
hopefully in the future we can reach this decouple, like what happened in other places.
And that's exactly the target of the O-RAN, right? And that's the entry of the new players in the market, like Mavenir, like Altiostar, like Parallel Wireless, and these new players in the market. So what they're doing basically, they are they are still virtualizing the BBU, or they are virtualizing what we call the DU and CU, and keeping the RU, which is the antenna, still in the BTS. But they are trying to open the interfaces between the CU and DU and the RU, which is the eCPRI interface. And this means that you can have the RU from a vendor X, and you can have the DU from vendor Y, and hopefully the CU from vendor Z, and having an open interface between them, so there is no any lock-in to any certain vendors. And this is a very disruptive move in the market, because the radio has been always what we call the cream of the cake. That's where the money is coming to the vendors. We have seen, and I'm sure you have witnessed the same. The core deals and these kind of deals are normally provided free of charge, based on a mega radio deal. So the radio deal is actually the radio is the part where all big vendors are focusing on. So if you now are going to have the CU and DU from software player like Altiostar or Parallel Wireless, so that's a complete shift in the architecture. This will decrease dramatically the capex and the opex paid by the operators. So as a trend, we see many operators are going this direction. Vodafone has been leading in that. You see Rakuten in Japan, and we have seen some official announcements from operators in the Gulf, like Etisalat, doing POCs. So it's a very, I would say, it's a very disruptive technology that actually needs more attention from all vendors in the community, because if big vendors do not see this wave and do their, I would say, either join or I don't know, maybe have some sort of reaction, the result will be very disappointing for them. And we have seen already Nokia and Ericsson joining the O-RAN alliance, if I'm not mistaken, like from few weeks. So that's again a shift in the way of thinking, right? That this wave is big, right? You cannot avoid such a threat. But let's emphasize, Radwan, that the O-RAN is not a 5G technology. The O-RAN is there for the 4G. The O-RAN is there for the 3G. The concept applies for all generations. Okay, it's not just for 5G.
But as you mentioned, Karim, again, we're still in the same era. We call it SDN era or something. That the main two, I think, requirement, or the main two dream, people talking about decoupling and abstraction automation. So maybe everywhere we are trying to accomplish this requirement in Nirvana, So I mean, maybe as you mentioned, for a green field, maybe it will be very appealing if like Rakuten and these guys, if an operator starting from a green field for 5G, this will be a very appealing and cost-effective solution to start with something like that. Yeah, but
I agree.
I agree with you.
Yeah, and even this point is true, 200%. Deploying O-RAN or as in a green field, that's the sweet spot for the vendors and the service providers. Having them maybe for an expansion covering new areas, but in a brown field, it has a lot of challenges.
Maybe as I mentioned, the last bit for now is what about orchestration? And
yes. So orchestration in 5G, 3GPP have never talked about orchestration before the 5G. So other standardization bodies like ECNFV, TMF, TM Forum, some initiatives like ONAP, Open Source Mono. So for the first time with the 5G introduction, the 3GPP has introduced a framework for 5G management and orchestration. And it became really vital because of network slicing. And before that, let me just stress that the 5G core is a complete virtualized core. There is no physical 5G core. So all deployments, all the even in the standard, it's mentioned that 5G is based on virtualized or based on NFV, I would say, a framework or NFV deployment. So the full 5G core is virtualized. So basically, even without slicing, you need a framework. You need an umbrella to manage the lifecycle management of the virtualized network functions of 5G and the virtualized services. So orchestration on the resources level, it is there, it is needed, it is mandatory. But this might be there as a brownfield integration. You can reuse maybe your VNFM, NFVO, doing the same thing before, like lifecycle management of VNFs, scaling, healing, instantiation, and so on and so forth. But the new thing that when I tell you that slicing is dynamic by nature, when I tell you that you can lease hundreds of network slices in a dynamic way. So you lease it to a customer, and then he said, okay, I want it for 1 day, and then you take it, and then you change its location from the edge to the core. So it's a very, very dynamic governance of slicing. You cannot do that without an orchestration framework that doing the network slicing governance. So we started to see from 3GPP new functional blocks that handle the lifecycle management of network slicing, something like the CSMF, which is the communication service management function. This is handling what we call the customer-facing service part. This is how you I would say you expose or how you sell the service to the enterprise customer. And we start to find functional blocks like NSMF, network slice management function. So that's a new functional block that handles the lifecycle management of the end-to-end slice that resides on the 3 domains that we previously talked about, the RAN and the core and transport. And there is the NSSMF, the network slice subnet management function that handles the lifecycle management of the slice subnet that runs on each domain. So there is now some sort of 5G orchestration framework defined by 3GPP, and most of the vendors now are taking this framework and mapping these new components to their orchestration solution. Okay, so that's a new thing.
That's interesting. Really, actually, this is some of this is completely new for me. I found it interesting, and maybe we can have a dedicated session talking about that. And as example, if you have an already existing, as you mentioned, the NFV architecture was NFVO and your VNF manager and so on. I believe most of this component will interact with mainly the VNFO, but we need to discuss in details how this can happen, and maybe VNF manager.
Actually, you know, the 5G orchestration is a very big topic. We can even have like a dedicated session for that.
So I believe next we will talk about network. What are the requirements from the network to support the 5G? We will discuss some of the integration and migrations scenarios, and maybe we'll finish with some of the required skills and resources. So stay tuned.